All right. We'll get started. Hello, everyone. This is my first talk on a compiler, so explain what I know about compilers. Matt's the creator of Ruby on Rails, or not Rails, sorry, creator of Ruby, Dr. Ruby, about 30 years ago. Created this Ruby to C compiler. Haven't known how to pronounce it. I think it's Spinel. It's based off of gem. I had to look it up because it doesn't actually explain here what the name is referring to, but I'm going to call it Spinel. It's a Ruby AOT ahead of time compiler. It's very new. If we look at the commit history, if we look at it, find a file, it hasn't changed. This author's file. This is the initial commit. Started this March 16th, so it is extremely new. Another thing that's interesting about this is we use it in Claude. It's very heavy with the Claude agents on here, and if we look at the commits, they're cranking away at it. So this whole page is pretty much from today and yesterday. It's not versioned at all yet. There's no tags, a handful of branches, and there's instructions way at the bottom of this on how to build it. So what I'm going to be showing tonight is this project as of this past weekend, which is already out of date. So already way out of date. So take that as you will. Before I dive into this too heavily, though, okay, we have a Ruby to C compiler, but what problem is this trying to solve? I think there's been a lot of talk over the years on Ruby performance, which calls into question why Ruby, why we want to use Ruby. There are more performant low-level languages out there. I think to answer that question at a high level, I'm going to refer to DHH and the Rails doctrine, which a lot of this covers Rails, but here DHH sets up 9 pillars of standards that Rails follows. Their whole why, their mantra, why Rails is important, and at least 2 of these I think apply directly to Ruby. One is optimization for programmer happiness. So the developer is seen as they're given a higher level of importance than the code. Obviously, the code has to work. We need to build stable software, but the experience of the developer is important because we're ultimately working on it. And in my experience, code passes between hands all the time. So it's very common to come across a code base you've never seen before, and you have to quickly figure out what's going on and try to do the work that you need to do it. I won't read all this out, but towards the bottom is an example of opening an IRB session and the intuitiveness of IRB versus Python. So in Ruby, you can type either exit or quit to get out of an IRB console. Versus Python, it's a little more explicit. I mean, they tell you what to do, but Ruby is more about the intuitiveness. In fact, there's something called the principle of least surprise that they talk about here. In my own experience, one of the things I really started doing, one of the things that really drove Ruby in the beginning was actually the enumeration module. So we go into an IRB and jump the scene here real quick. Look less. I do an IRB and I make an array of X to 1, 2, 3, right? Most languages have a way of mapping over it to do some operation on it. So you do for and do for
1 plus.
yeah. Read that. Okay. You get number plus 2, right? And that will return all the numbers with 2 on them. You can also do filter. You can do want to get all of the odd numbers. I'll do that. I can do even. But Ruby gives you more than one interface for the same thing. So I can do select, which gets the even values, or I can do the inverse, which is reject, which will be the same as not even. So I change the odd, get the same output work. So Ruby is just more intuitive that way. At this level, it seems like, okay, it's not a big deal. I can learn the interface I need to learn, but when you're coming into a code base for the first time, stuff like this makes the developer experience that much smoother. Certainly Rails adds to that if you're working in Rails, but Ruby as a language really lends itself to predictable, surprise, intuitive behavior. The other pillar that is relevant to Ruby is exalt beautiful code. And part of this is readability, but part of this is being able to quickly look at something, quickly interact with something, and understand what it's doing. I think my favorite blocks of code are methods or functions that almost read like a recipe list as to what the instructions are. So you have like the top level caller, and it explains like, okay, fetching some data from an API, I'm transforming the data, running some calculations, I'm saving it to a file. Things that are clearly descriptive. Ruby lends itself more to that. In this example, they have a model class from Active Record. And there's a lot going on here if you know Rails, but even if you don't know Rails, you can get an idea pretty quickly as to what this represents. We have a class, or we have a project, belongs to an account, has many participants, and it requires a name. So even someone that's not a coder can pick up on some of this. You don't have to know that it's connecting to a database. You don't have to know how it's connecting to a database. You don't know how it's querying data. You need to look at that part, then you can learn that part, but just at the surface, you can see, okay, we have a representation of a project here. So there's just a couple of things that make Ruby a preferable language to work in. Developer happiness and beautiful code. But what are some of the complaints that people talk about with Ruby? Well, performance. So let's see if I can find the benchmark thing I was looking at earlier. Benchmark. Okay. So this is a benchmark page that is comparing.
This is the great programming language shootout.
It's called Programming Language and Compiler Benchmarks. I guess they compared wide variety of languages against each other. Some of your common times. So this is comparing Go and Ruby, and what are we doing here? Well, even your basic hello world. Ruby is 0.6 milliseconds. Go is 0.1. Stuff that were like, up the games are down here like Sudoku or Connor's Game of Life, but nonetheless, HTTP server, Go, that's only Go. Go back to the top. Binary trees, Ruby, about almost 5 seconds. Go, 2 seconds, 2 seconds. Maybe the minified Ruby too. That's probably that's trouble Ruby.
Look at that standard deviation. That's
Deviation.
exceptionally high.
So, people will read stats like this and be like, well, okay, especially if they're coming into Ruby and they're going into Rails and they're spinning up an app very quickly, and they scale to a point where they're experiencing slowdowns, and naturally they're looking for ways to speed up their application. So they'll hear developers talk about language performance, especially with the lower level languages, and then they'll see stats like this. It's like, well, gee, I got to get off Ruby because it's so much slower than Go or Rust or there's a wide variety of languages. And sure, there's some truth to this. One thing I will suggest here is a good read. This book I read last year called Rails Scales. This is specifically Rails, but this book, they advocate that you can't actually scale a Rails application to a large number of users, even if you're doing heavy calculation stuff. But two of the main issues that tend to come from Rails are caching or lack thereof, and poor database queries with active records, which I call these out here. They're not relevant to Ruby per se, but they are relevant in terms of you're comparing languages. You have to kind of rule out that you don't have other issues with your application that are slowing it down. So if you have poorly written database queries and you port it over to Go, maybe as part of that you will rewrite your queries. But in theory, if you were to take your application, rewrite it in another language, and keep the same pattern, then you may not get the same level of performance boost as you might see in these benchmarks, because you have other problems that are outside of the programming language. So I just thought that was worth mentioning for anyone that's looking at this or comparing languages. I think the architecture is an important consideration. Also, developer happiness is an important consideration. But I have enough of that. We'll talk about Spinel now. So I'll spend a little bit of time going over its README. So how it works, it's kind of a pipeline. So you write your root file. When you run Spinel, it will go through a parser. That parser will convert the Ruby code into an AST, an abstract syntax tree. And I think this is essentially be viewed as like a tree diagram. You can use the right diagram. You can use it to, I think, convert it to other languages. I haven't spent too much time on that, but essentially this becomes the template for conversion into C or other languages. You go through an analyzer first, and then that gets piped into a code generator, which will generate your C code. The C code will then be run through your standard compiler on your operating system and will spit out a native binary, which can then be executed standalone. And here they have a demo where you make the Spinel project and then you write a simple hello world, write that to a file, run it, and then that generates an executable on your file system, which you then just run it standalone. Here are the runtime options. So by default, it just generates the file with the same name. You can use the -o to give it a different name. You can use the -c to only generate the C code. You need to evaluate that. You can use the -s to print out the C code without writing to a file. I don't know what this -rbs is. I think this is new. I haven't looked into that for long yet. So here you have some benchmarks. The product I was thinking of earlier. It's got the Runways Game of Life, Sudoku, various games and computation things. So you got your Ruby metrics and your Spinel metrics. And down here, there's also some real world scenarios. I think JSON parsing and CSV parsing I've seen done a lot of that. Some moderate benefits there. So 6.7, 3.6. Here's a wide list of Ruby functionality that's supported. We're going to touch a bit upon this later. I think this is a good conversation. I don't know if it's entirely accurate. It's accurate, but Ruby's not statically typed. C is, so that's going to come into play later. Talk about optimizations. A lot of this is honestly above my head, so won't talk too much about this, but they do talk about how they do the C optimizations. And I guess this is the architecture project. How you do each part of the pipeline. How to build this project. And then the limitations. So limitations are important to call out here. So basically no metaprogramming, no threading, and no lambdas. This rules out compiling a lot of the code you find at the Ruby standard library. So CSV file parsing, YAML file parsing, some other stuff you would usually reach out to within Ruby.
So there's no runtime system.
There's basically correct. You're just taking raw Ruby code and you're compiling it into C. And I guess anything that you included in the Ruby, it would have to then compile that too. But a lot of that, the amount of experimentation I've done does use, things like eval or metaprogramming. Probably not Reddit, but eval and send method, this and find method. These are supported. So now that we've gone over that, let's look at some code. I'm going to jump out of here. I actually have a few examples.
Do you think that that's a design tenet, or do you think that just reflects the state that it's in right now? What I mean is that it not having its own runtime system, it's just translating it to C as best as it can.
Right, and I think the idea is to run it as if it were a static standalone thing. Because you want to run it runtime, then that's what C Ruby does. That's what the interpreter does. So we're trying to optimize over going through the Ruby interpreter. So like this defined method or set that would require runtime evaluation to complete. So I have a couple example Ruby applications. So simplest one is a hello world. Interestingly, I found out string interpolation does not work. So I can't do hello name. It will compile. It will then print out a number instead of the name. So I'll show that running Ruby example 0 line. So I can call time in front of that, and it'll tell me how long that's up. 0.7, 0.7, 0.7. I can use Spinel to zero. It can pop the binary. I can run it, and it ran. I do time in front of that, 0.01. So, yeah, even in simple hello world. Yeah, that a few other examples. I think it's like a point map thing. Yeah, that point map. Example 1 time 172 is probably about the same. I file that. Yeah, 0.01. Found that when you make this project, it only gives you the option to give it a Ruby file and compile it. You can't really get in the middle of the code generation pipeline, but those executables are there. That's I think kind of a way to run that. Spinel, parse. Yeah, Spinel parse. If I run that, I can actually see the abstract syntax tree. So if I need to evaluate the tree, I can do that. And then as the doc said, I could do Q-C. That's going to write it to a C file. So I can evaluate the C code. What's interesting here is the runtime header. So I haven't looked at too much at what this is doing, but this file has to be in the directory where this is being run in order for this to compile. So I can't generate a C file, make changes to the C code, and then compile it, because the header file isn't there. Header file is in try to find it. Yeah. Okay. So it's probably, yeah. So that has to be in the same directory. So we'll probably move this into that directory and run it.
Can use minus capital I think, to include other directories in GCC.
I haven't tried GCC yet. You're saying dash
It's
I.
probably a similar, but yeah. Dash capital I, no spaces, and then the path.
Try that.
I think. What did it say? Oh, now it doesn't have the C file. Or, yeah, it doesn't have the binary object.
Is it in the wrong order? Have to get the file first.
No, you have it right. I mean, see, this is a linker error. This isn't a compiler error. So it tells me that those definitions are not in, they're not in the linked, there's supposed to be a dynamic object that would define those normally, I would think.
Yeah, you need your LD load path or dash capital L, something to specify where those are stored. They're there on your machine somewhere. And those are math, so wherever the math library is.
You can, like, you can run obj dump or something like that to see what, dependencies. Oh wait, you would need the dynamic object. So never mind, forget that part.
Yeah. You can come back to that.
Yeah.
We're interested. So we have a Lucy file. We can at least see what's going on there.
Yeah.
The main function down here. Let's follow at the end. I want to show a different project now. Bump out of here. Go to this aggregator. I did actually set up some examples in Ruby, Go, and Elixir. So we compare more of a real world scenario here. So Claude generate a CSV of 20,000 rows of page sales data. It's got dates from the beginning of the year to now. It has them out. Some of them are positive or negative. So the goal of the script is to add everything up, add the sales, add the refunds, group them by month. So if I do sales summary, it'll take a couple seconds, but it shows my overall total, how much it was sales, how much it was refunds, and then group by month. And show this took considerably more time than that hello world. 0.6 seconds. 0.6 seconds. If I look at the code for that, we're using the CSV library for reading that in, reading the rows. Get a little more room there. I'll zoom in for a sec. Get total is greater than 0, total is less than 0, grouping, and then printing everything out. So CSV parsing and aggregation. I have another example in Go. Go run sales summary Go. That's a little less time, 0.05 seconds. And I look at that. It's also using libraries, LX library for opening the file, format for printing, yes, string conversion things. The same code. I have an Elixir script. Summary, which this is also using a CSV library. You have the path, you have the file, parts CSV, we're grouping it, and then we're putting it into an looks or not for each item, and then we're using enumeration to stuff and filter and finally print. If I run that, won't run as fast as you think because it has to compile. It's 0.9. It's actually slower than the Ruby example right now. You can pre-compile these. So I have a sales summary folder. This is a pre-compiled Elixir example. 0.3. So Go is still kind of winning out here. Now with the compiled Ruby example, I've already compiled it in sales summary compiled. Trying to get time behind it. 0.01. So considerably faster than even the Go example.
Can you open up the Ruby file again, please?
Yeah, so I'm getting to that. It's the Ruby file is actually going to be different for the compile. So this did not work for the compile. In fact, I tried to compile it. I get errors on, well, unendless constant. That has to do with requirement, but a lot of cannot resolve to integer types. Basically, what I found is you don't have to define the types, but you do have to define the variables with some initial values for that type. So that was what ended up being the file version for this. I was able to use file to open the file, but all of the things end up being totals. I have to kind of predefine them. I think I did have AI help with some of this, but I'm wondering if we have to define array lengths too. I haven't experimented with that part, but I found that you need to give things initial values. So in this version, read the file, setting up some default totals, and then iterating through each row. So that's CSV, then doing the aggregation. So yeah, the Ruby code had to change.
So is it the call out to CSV that didn't work?
It was the inclusion of, it didn't pick up the required here.
Okay.
Complained that CSV wasn't a constant.
So if you had only compiled from line 5 on, do you think it would have worked? Like if you had, like, I guess the question is, how do you integrate this into a project if you're just, or are you trying to compile the entire project? You know, are you able to compile just snippets and call out to them?
You can. I think the goal is to file like just the flat code that you're going to be doing computations with, not anything that's pointing to libraries so much. I ran this again, it's still going to fail on not resolve all the rows. Oh, that's good. I didn't have it here. So it's, I think it is failing because I had problems with empty arrays too. Call to yeah, I do have an issue with empty arrays. What was your question again, Stuart?
It's basically like, can you compile just snippets of code and include those in a, for example, a Rails project? Or is this designed mostly for standalone Ruby programs?
You can give snippets to it. That they're get an example up here where they do just that. They're writing for the file, but you can I thought I put the helper before we should give it code directly. Where did I see that? The dash E. You can use the dash E option to give it a Ruby string. So you'd have to reach out to this is an executable within your project and file it, which I don't know if there would be benefit in doing that at runtime. But it is possible to get snippets. I'm going to show another example shortly of something that's dynamically building something to compile, and then it will be run. I might even switch over to that now. I think I have the file that I show here. So takeaway here is that it's definitely faster, but already having to jump through some hoops to get the Ruby code in such a way that it will compile. The next project I'm going to show is within Rails. Within Rails, but this is where things got complicated. I got it to work, but there's some things to be desired. I'm going to start by yes, right. I'm going to show what this is first. Reset this database. And so it's kind of an order management page. Here we go. So pretty much I plot scaffold most of this. What I wanted to focus on was the CSV importer. But this is a standard order front setup. I can do filters, do all the nice front app things. I have a CSV importer, and I have two files here. One has a validation issue. One is working. We'll go to the one that's working first. Import is going to go off to its import thing, and then in a few seconds, 7 seconds later, we get a message that 3,000 rows were successfully imported. The way this version works, this is entirely in Ruby right now. If I go to the order controller, I have an endpoint that is import, takes a file, passes it along to the order model, import from CSV. The import from CSV takes the file, opens it with CSV, instantiates a new order object, and this is a Rails, so we call valid on it. And calling valid is going to check all of these validations listed up here. So a lot of field presence validations, there's uniqueness validations, there's project pattern match validations, verticality validations. So it's going to check all these things for each row. The ones that are marked valid get appended to the valid orders. The ones that failed get appended there. The ones that failed succeeded, get sent back in the successes versus failures. And then the ones that were valid get sent to this import. This is active record import. Basically does an insert all SQL. So to do a batch insert directly in a SQL. So surprisingly, the computation effort is less in the object instantiation. It's and it's certainly less in the import, as it just really calling out to SQL. There's a little bit of time spent in CSV parsing, and there's a lot of time spent in the validation. I'm going to switch to my other branch here. Reset. Back up. So database reset, track 30 orders. Want to import. We'll do my invalid file now. We may have 2 records here that are invalid. That completed in 0.9 seconds and gave me the 2 rows that failed. So I have posted my 3,000 orders minus the invalid ones. So spent a lot of time in this odd scenario. Basically, like if I wanted to extract my validations, how would I do that? Don't have to go too heavily a lot of AI, but what I was playing around with was extracting the validation rules out of the model into a consolidated YAML file that would then split out the logic between what Rails has and what is going to be precompiled. So I had to create a YAML file that just lists out the rules. So order number must be present and unique, quantity present, numericality, etc. And then on the model we're validating in Rails, we just load those validations there. And then there's a validation loader that would reach out to the Rails validators that are already in place for those things. But if we're doing an import, this has changed quite a bit. So I'm now loading the file and reading the file path, and I'm sending it off to my precompiled executable. And that's going to tell me which rows were valid versus invalid. The ones that were valid, I'm still taking those and passing them off to order import, my batch insert, and then the ones that were failed, I'm going to show the errors. So essentially, the CSV parsing was extracted, although I'm now doing a JSON parse, so probably lost a little bit there, but the validations were extracted. And this is where things get messy. So how do we make that? There's a rate task. First part, it defines the rate task. So I'm using this to compile it. I read the relevant validation file. I'm pulling the fields that we're going to validate on somewhere farther down the rules as well. So we're basically building that. I'm pulling in another template, and then I'm reading from a few things and then writing to a single Ruby file that will be filed, and then I'm running the Spinel file or the Spinel executable on that file to become the importer. So this Spinel main is kind of the less dynamic stuff. So it's the CSV parsing. There's some row to JSON things that at the end converting to JSON. The part that's important is reading the file, tracking valid or it's invalid, and then calling check row on each. So iterating through the lines, parsing it, and checking the validations. And at the end, outputting the JSON. The part that's dynamic, kind of heavily dynamic, is actually constructing the validations. And this is where I kind of ran out of time on building out this example. I kept hitting walls with compiler errors that were a lot to do with integer data types and arrays. So yeah, I'm having to construct the validations dynamically based off of the field and the rule, Ruby first, and then writing that into Ruby. That becomes the compiled version. So I can run break Spinel file where that's going to make the order importer. What I was wanting to do, or I had it on another branch, I'll just kind of pseudocode it version. But wanting to do is make a class here that's a field validator that validate. So have it on it, validate basically. The initializer will take a field, a value, rules, and then the validate would essentially track errors and then iterate through each of the rules. And then, if I guess figure out the rule name. If the rule is presence, then check it. Value present, and if not, then end of the errors. People can't be blamed. But I got a lot of errors, I got a lot of compiler errors on blank or empty arrays. It was expecting it to be an integer array, essentially. I'm trying to see if I have maybe an example I can show of that error. This is the last branch I was with. It was like this. Like here. And then, all right, that's what minutes, wasn't it? One more effort. Okay. can't find it, but yeah, I was trying to write more consolidated Ruby classes, even if I had to compile those first. But it got a ton of very odd compiler errors around arrays. So I think the takeaway from this whole thing is there's a lot that's been done in a couple of short months on this, and they're working on it pretty much around the clock. I'm interested in seeing if it's going to be versioned anytime soon. I do think this has potential. I think the documentation around what's supported is, and part of my lack of experience at C, but I think seeing more around the supported features in Ruby is what I'd be looking for, and more of a clear delineation as to what's supported in Ruby and what's not, especially as it pertains to data types. So I'm able to work with it, but I'm having to change the Ruby code a lot to make it work in the for my use cases. So that's kind of where I landed on this. Any questions?
I don't really have a question. I've got kind of a comment, I guess. So it seems like, the workflow, like like something that could work, like in a real project, like the way you've done it in this project right here. You write a program with some CPU heavy code, and then you shell out to that, and then you've got a faster function. I think it would be more interesting if you could compile a Ruby function and then call that function or something like that. That would be like foreign function interface or something like that. That would be real.
So you just say the function.
Yeah, that's how you would do it in the Java world or the Haskell world. Is you would just take your most expensive pieces, write a C function, and then you would use the foreign function interface to call that C function.
So it would run. Trying to think of how that would work in
Yeah.
interpretive environment. So basically, function is written in C, but it runs in the Ruby runtime.
Yeah.
Yeah. I've seen languages that have that call out to
Yeah. I mean,
another language thing, but I'm always thinking that it's really going out and shelling to some executable.
yeah. I mean,
not, it's
when it
going-
comes to calling C functions, there's usually like a calling convention that when you write the function, you have to set it up, however the interpreter expects it to be, and vice versa. But I know, like with Erlang, the way that you call out to other functions, it just sets up a byte string, and it streams it back and forth between the process. So I don't know.
Yeah, I've seen the Erlang one. I thought the reason that would work really, you're already running in the Erlang interpreter.
Yeah.
And so I guess the same.
Yeah, I mean, you can in Erlang. My understanding, and it's probably wrong, is that you can interface with any other language, and the way that works is you're just sending byte streams back and forth. You're just sending messages,
right,
between the process.
Yeah, that's how the native extensions work with some of the gems, and they call out the same way. I did a quick search. I found one proof of concept that for regex that somebody did to spit it out as a C Ruby extension.
Yeah, Yeah, so I think I do remember in the early days of maybe not the early days of Ruby, but um, whenever was poking through the source, a lot of the functionality was written in C, like the base libraries and stuff like that. So there, I mean, there's got to be a way to call them C functions from Ruby.
Stuart, is that like, are those native extensions being loaded into C Ruby, or is that reading out to those things as a native executable, a native binary?
Yeah, it's a native binary that when you run bundle and you see building native extensions, that's what it's doing. It's actually running the compiler on your machine and setting up um, uh, basically a library that it can call out to.
Yeah, that makes sense.
Yeah.
Any other questions? Okay. Thanks. That's all.
Yeah, thanks for bringing this up. It was it's an interesting project. And be interested to see where it goes.
Sure, and stop the recording. Uh,
Yeah, it would be interesting to see if they could eventually make it basically plug and play, where you could just take a program that you've written and just translate it directly to C with, the C evaluation and all that stuff.
I'll just crash on me.
I was wondering, yeah.
I don't want to.
Well, I can still see myself moving, but I guess it's your screen that's frozen.
Switch over. Yes. Yeah. I lost.
Disappeared.
So you'll be doing it. There we go.
There you are.
Recording.